Welcome back to lesson 6 that is about infinite limits, and limit at infinity. Limit at infinity means what is the limit when x approach to infinity. Infinite limits means that maybe when x approach to, the function approach to infinity. The value of the function approach to infinity. So these are the two ideas that we are going to study. We will review this, or maybe we have reviewed already the definition and the theorems and the summary and all the example. And this is done during the class, and we'll go directly to see the problems. Now, let's go to see this problem. Determine whether the function 1 divided by x minus 4 approach to infinity or minus infinity as x approach from the left. So x approach from the left means that x approach 4 negative, approach the number 4 from the left. Okay, how we will draw this function? If you draw 1 divided by x, this is the 1 divided by x is not defined as x equals 0 because you cannot divide by 0. So the graph of 1 divided by x is this graph. What will be the graph of 1 divided by x minus 4? So what you will do is to translate the graph 4 units to the right. If you translate the graph 4 units to the right, the graph that will appear will be this one. This is the function. This is x equal 4. This vertical line is x equal 4. And as you see, the function, when you approach from the right to 4 positive, the function will go to plus infinity. As you approach with to the number 4 from the left, 4 negative, the function will take in numbers very, very big. As you approach from the left next to the 4, the function will go very, very down in the negative to a big number. So let's go to do some numbers to figure out what happened. What happened is if x is 4 positive. If the number x is 4 positive, means that the x is 4.001. The function is 1 divided by x minus 4. So it will be 1 divided by 4.0001 minus 4. And this is a positive number, it's 0.001, expressing like 10, like exponential function. It will be 1 divided by 10 minus 4. 10 minus 4 is 0.0001. So 1 divided by 10 minus 4 is a big number. It's 10 to the 4, it's 10,000. So when x is 4.001, it's 10,000. When x is 4.0000 and one more 01, it will be 10 to the 5. So as you approach from the right to the point to 4 positive, the number will be bigger and bigger and bigger. So when you approach here to the 4, the number will be every time bigger. We say that x equal 4 is a vertical asymptote. What happens if x is 4 minus? If x is 4 minus, you are approaching from the left. So x is something that is 3.9999. So what will be the value of the function? It will be 1 divided by x minus 4, or 1 divided by 3.9999 minus 4. It will be 1. Now this is a negative quantity, 1 divided by minus 0.001, or minus 1 divided by 10 minus 4, or minus 10 to the 4. So as you are approaching and you're getting closer to the 4 from the left, you are going down. The function takes value that are going higher, negative, going down, are going to the minus infinity. If you take x equal 3.9999999 many nines, you will go to minus 10 to the 10, maybe. You can arrive to the infinity, so it means that the limit doesn't exist because you don't arrive to any fixed point. So when this happens, we say that we have x equal 4 like an asymptote. So we have answered this problem. What happened when x approach minus infinity at x approach from the left to the number 4 from the left to the right. Let's go to this problem number 2. Is something similar. Is determine whether the function minus 1 x minus 4 squared approach to infinity or minus infinity at x approach 4. Well, at x approach 4, from the right or from the left, this quantity will be always positive because it's a square. So this quantity, the denominator, will be always positive. The numerator is negative, so the quotient will be negative. So if it approach, should be approach to minus infinity. So let's go to use the concept of the limit. So I approach the number 4 from the left or from the right, it will be the same. What will be? First of all, let's consider that instead of asking this question, they ask, what happens when x goes to the infinity? It means that x is a big number. Let's say that x is 10 to the 6, 1 million. What it will approach the x? When x approach a big number, not the 4 like the problem is saying. I'm just trying to solve another problem to get the idea. So when x approach a big number, this will approach to minus 1, x minus 4, 10 to the 6 minus 4 squared. But you can think that 1 million minus 4 is almost 1 million. So it will approach to minus 1 10 to the 6 squared. And 10 to the 6 squared is minus 1 10 to the 12. So when you divide the 1 into a big number, you approach to 0. So when x approach to the infinity, the function approach to 0. Wow. So let's go now to solve the problem. To solve the problem is when x approach 4, let's say that x is 3.9999. To what the function will approach? If x approach 3.99, so it means 4 negative, this is approach 4 negative, the limit, the function will take the value minus 1 divided by the point x minus 4 squared. The point x is 3.99 minus 4 is 0.001 squared. So this will be 10 a la minus 4 squared, or 10 a la minus 8, and it will be 1 divided by 10 a la minus 8. 1 divided by 10 a la minus 8, and there is a minus sign, that is this minus sign. So this is minus 10 to the minus 8. Okay. This is minus 10 to the minus 8. So it will approach to a big number, but negative, in the negative direction, going downwards. So as x approach 3.9999 from the left, it will approach to a very big number. What happens if I approach to the 4, but I approach to the 4 from the right? So I approach from 4 positive, and I approach with the number 4.0001. To what it will approach the function? It will approach to a big number that is also negative. Let's go to do it. It will approach, f of x will approach to 1 divided by x, 4.001, minus 4 squared. So it will be minus 1 divided by 0.001 squared, or minus 1 divided by 10 minus 4 squared, or minus 10 minus 8. So as x approach 4, in both cases they approach to minus infinity. It means that the graph should be next to the 4, next to the point 4. The graph should be something like this. It will approach, this is the asymptote, and it will go something like this. Okay, let's go to the next problem. Find the vertical asymptote of the function x squared divided by x squared minus 4. Well, we have to be careful about this, but the asymptote can take place, not always. When the denominator is 0, if the denominator is 0, is when x squared minus 4 is 0, and this is true when x equal 2 or x equal minus 2. So here there are two asymptotes. We expect to have two asymptotes, one at x equal 2 and one at x equal minus 2. Now, how they will do? In x equals 0, the function is minus 4. At x equals 0 minus 1, 4. X equals 0, at x equals 0, the function is 0. Because it's 0 divided by 0 squared minus 4, that is, will be 0 divided by minus 4, which is 0. So at x equal 1, the function will be negative. 1 divided by 1 minus 4, which is minus 3. Or at x equal minus 1 will be the same. So the function, I think, will do like this. As x approach 2, the function will approach when it approach to x equal 2, it will approach 2 minus. When it approach to 2 minus, it will approach to minus infinity. Here, when you are outside the asymptote, here they will approach to the infinity, and it will be something like this. When x equals 3, the function will be 3 squared minus 9 minus 4, which is positive. So it will be 3 squared, which is 9, 9 minus 4 is 5, 9, 5. 9 divided by 5. When x equals minus 3, will happen the same thing. Yes, will happen the same thing, 9, 5. Okay, so this can give you, the asymptote can give you the idea how you can draw the graph of the function. Okay, let's go to the next problem. The next problem says find the vertical asymptote, if any, of the function f of x equal x squared minus 1 divided by x plus 1. This is what I was saying, that you have to be careful that not necessarily when the denominator is 0, it appears an asymptote. It may not appear. So when x plus 1 is equal 0, x equal minus 1, but this is not a vertical asymptote. Why? Because when you do the limit from x goes to minus 1 of x squared minus 1 divided by x plus 1, if you factor x squared minus 1 as x minus 1 multiplied by x plus 1, like we have learned in previous lesson, divided by x plus 1, this will be cancelled, so it will state as the limit when x tends to minus 1 of x minus 1. When x tends to minus 1, the value of x is minus 1. So minus 1 is minus 2. So the limit, it arrived to a fixed point when x goes to minus 1, and this point is minus 2. So the function is not defined at this point. The function indeed, if you divide y equal, remember that this is x minus 1 by multiplied by x plus 1 divided by x plus 1. So the function is the same function that x minus 1. This is the function y equal x minus 1. But the function, this one, is the same like this one with a hole here. Is not defined at x equal minus 1. So this is an interesting concept. This function, if you make the algebra will tell you that this is x minus 1, which is a rectilinear line. But this function is not this one. This one is only valid, this is valid only when x is different than minus 1. When x is different than minus 1, this function is not defined. So it has a hole here. So these functions have the same rectilinear line, the same values that have the rectilinear line, except that in x equal minus 1 have no defined value, because you cannot divide by 0. Minus 1 plus 1 is 0. So you cannot divide by 0, so the function have no value, no defined value. So let's go to the next problem. The next problem says, find the limit of x plus 3 divided by x squared plus x minus 6. So we factor the denominator. You use the quadratic equation, for example, or you use a technique to factoring. The product should be minus 6. The sum 3 plus 1, the sum 3 minus 2 should be 1. This factor, you remember for algebra. Okay, so let's go to this limit. The limit when x approach to the point minus 3 negative. So you approach to the point minus 3 from the left. So it will be x plus 3 divided by x squared plus x minus 6, but it's x plus 3 multiplied by x minus 2, so it's the same. So this will be cancelled, so it will be the limit when x approach minus 3 negative of this expression, 1 divided by x minus 2. When x approach minus 3 negative, the value of x is minus 3. 1 divided by minus 3 minus 2 is minus 5, so this limit will be minus 1/5. So when x is minus 3, this is the lesson that you have to learn. When x is minus 3, this is 0. The denominator is 0. This doesn't mean that there is an asymptote. It could be that the limit doesn't go to infinity. In this case, in this particular case, the limit goes to minus 1/5. So it's not an asymptote. Okay. Now let's go to find the limit when x goes to infinity. Now is the second part. Limit at infinity of x squared plus 2 divided by x cubed minus 1. When you do limits at infinity, you divide by the higher power that you have in the denominator. So we divide by x cubed on the numerator, and we divide by x cubed or the expression in the denominator. Dividing by x cubed in the numerator and in the denominator will not alter the value, as you are dividing the numerator by the same amount that you are dividing the denominator by the same amount, so it will not change. So it means that 10 divided by 2, that is 5, is the same that 10 divided by 2, 2 divided by 2. Oh, yes, I have divided the numerator by 2, the denominator by 2, and I have not altered the number. 10 divided by 2 is 5. 2 divided by 2 is 1, is 5. And 10 divided by 2 is 5. So dividing by the same number, it will not change the expression. So I'm dividing by x cubed the numerator and the denominator. When I divide, x cubed divided by x squared divided by x cubed, it will be 1 divided by x. 2 divided by x cubed, when x goes to infinity, 2 divided by infinity is a number that approaches to 0, so the limit will be 0. And x cubed divided by x cubed, when x approaches to the infinity, it will be approached to 1. And minus 1 divided by x cubed, when x approaches to the infinity, 1 divided by something very, very big is something very, very small, approach to 0. So the limit will be 0 when x approaches to infinity. 1 divided by infinity approach to 0. 0 divided by 1. 0 divided by 1 is 0. You can't divide 0 divided by 1. You have nothing, you divide by 1, and you obtain nothing. What you cannot divide is 1 divided by 0. 1 divided by 0 doesn't exist. This is not allowed. Division by 0 is not allowed. So when the degree of the denominator is bigger than the degree of the numerator, as x tends to infinity, the function goes to 0. This is a rule that always happens. Okay, now let's go to the next problem. Problem 7. In problem 7, say find the limit. Now the degree of the find the limit of this expression, x squared plus 2 divided by x squared minus 1. As x tends to infinity, limit at infinity. Now the degree of the numerator is the same degree of the numerator, degree 2 in the numerator, degree 2 in the denominator. To what it will go the quotient of the two functions. So when x goes to infinity, x squared plus 2 will be more or less x squared, because if you have $1 million and they give you $2, if x is very big, $1 million square will be $1 million square, a lot of money, plus $2, it will be 1 million square. If they take you $1 for x tends to infinity for 1 million square, it will be the same 1 million square. So the limit, this limit, x squared plus 2 divided by x squared minus 1, is the same limit that x squared divided by x squared. But the limit when x goes to infinity of x squared divided by x squared, this is 1. So the limit is 1. And now let's go to the next problem. The next problem, guess what, should be when the degree of the numerator is bigger than the degree of the denominator. We have studied one problem with the degree of the denominator bigger than the numerator. Last problem was the degree of the numerator equal to the degree of the denominator, and now the degree of the numerator is bigger than the degree of the denominator. How to do this problem as x tends to infinity? Well, this problem is find the limit of 5 divided by x. When x goes to infinity, this goes to 0. Minus x divided by 3. When x goes to minus infinity, this part with the minus sign goes to plus infinity. But you don't know this expression to where it will go. Maybe it goes to a fixed number. You don't know. So you have to do some kind of a calculation. The first thing that you are going to do is to sum these two fractions. Of course, as x goes to minus infinity, the first part goes to 0. The second part goes to minus infinity. With this minus, it will go to infinity. But the sum, you know who is the winner. We don't know who is the winner until we do some algebra. So the algebra is down here. You make the sum of these two fractions. It will be 50 minus x squared, this by this, minus this by this, divide by this, 3x. So this by this, minus this by this, x squared divided by 3x. So this is the limit that we have to do when x goes to minus infinity. Now we do the limit, we can divide now by the lowest, when the numerator have a bigger degree than when the numerator have a bigger degree than the denominator, we have to divide by the lowest degree, by x. So if we divide by x, it will be 15 divided by x minus x squared divided by x, 3x divided by x. So this will be 1/3, x divided by x is 1, 15 divided by x minus x squared divided by x is x. So it will be 1/3, 15 divided by x minus x. Now, when x goes to infinity, 15 divided by something very big goes to 0. And x goes to minus infinity. When this minus, it will go to plus infinity. So this limit approach to infinity as x approach to infinity. And you can check it. You place a big number x here, you place a big number on the limit, let's say x equal 1 million, and you make the sum, it will be a big number. You make a bigger number and it will be even a bigger number. So this limit is plus infinity as x tends to minus infinity. Now let's go to do the next following problem, that is the limit of sine of x divided by x. So I remind you that the limit when x approach to 0 of sine of x divided by x, we have seen in previous lesson, this is 1. Sine of x looks very similar to x, to the function y of x, when x equals 0. At x equals 0, sine of x will look like this. Okay. And the function y equal x, it looks the same in a way that the quotient of the two is 1. Sine of x divided by x is 1 when x approaches 0, from the right or from the left. But here the problem is, so the function is not defined at x equals 0. This function cannot be defined at x equals 0. So the problem says find the limit of this function. This is the graph of the function. When x approach to infinity, not to 0, to infinity, what will happen? So the way to do this problem is to realize that sine of x is bounded between minus 1 and 1. Sine of x cannot be bigger than 1 and cannot be smaller, cannot be bigger than 1 and smaller than minus 1. Cannot be. So because sine of x cannot be bigger than 1 or smaller than minus 1, sine of x is between 1 and minus 1, always. Sine of pi divided by 4 is a number between 1 and minus 1. Sine of 5 pi divided by 4 is a negative number. 1, 2, 3, 4, 5 pi divided by 4 is a negative number and is between minus 1 and 1. So sine of x is always less than 1. So sine of x is between 1 and minus 1. So sine of x is between 1 and minus 1. Sine of x is between 1 and minus 1. So if I divide by x here, the expression will take the same relation. So when x goes to infinity, 1 divided by x goes to 0. When x goes to infinity, 1 divided by x goes to 0. So this is in a sandwich. So this will goes to 0. This will goes to 0. So these have to go to 0. It's called the sandwich limit when you when you can sandwich the function in the middle, because it's between these two, the middle have to go to the zero. So that's proof that the limit of sine of x divided by x tends to zero as x tends to infinity. As x tends to infinity, sine of x divided by x tends to zero. One way to represent this function is to write this function in this way. Sine of x divided by x is the same that 1 divided by x by sine of x. So when you want to represent this function, you can draw 1 divided by x. 1 divided by x is this function. This is 1 divided by x. And you draw minus 1 divided by x. Minus 1 divided by x is this function. Minus 1 divided by x. So this is 1 divided by x for positive value, this is 1 divided by x for negative value, and this is minus 1 divided by x and minus 1 divided by x for positive values. And sine of x, the limit when x approach of 0 of sine of x divided by x, this, when x approach to 0, it is approach to 1. So here is 1. So the function is not defined at 1, at x equals 0. It's not defined at this point. But the function will do like this. Sine of x do like this. Okay, it's a sinusoidal function. Sine of x, 1 divided by x by sine of x will do like this. You see, it's a nice function. You see, is not defined at the point x equals 0. If I want continuity by this function, I have to define f of x equal sine of x divided by x if x equals different than 0. And I have to define x equal 1 if x equals 0. In this way, I will find continuity. I can draw the function without taking my pen out of the paper. Because the function, remember, is not defined. This function like itself is not defined at x equals 0. Let's go to the... Now this problem say use a graphing utility to identify the horizontal asymptote. Horizontal asymptote occurs when x goes to infinity and the function approach to a finite number at the infinity. So if you use a graphing utility, you will see that this function, use GeoGebra, it will do something like this. It will do something like this, and as x approach to the infinity, you will see that this function approach more or less 1 to 2 point something, 2 point or maybe 1.9. There is a horizontal asymptote when x approach to infinity, and there is an horizontal asymptote when x approach minus infinity. You don't see here, but this is the calculation that we have to do. First of all, I have to say, on this function, it will never occur an horizontal asymptote. Because to have an it will never occur a vertical asymptote. To have a vertical asymptote, I suspect that I will need, not necessarily, but I will need the denominator to be 0. And you see 2x squared plus 1 is never 0. So it's never 0 because to be 0 means that 2x squared should be minus 1. If 2x squared plus 1 will be 0, 2x squared should be minus 1. It's impossible that a number squared multiplied by 2 will be minus 1. This have no solution in the real numbers. So let's go to do this problem, and let's go to do now the vertical asymptote. Let's go to do in some way the limit when x tends to infinity of this function and the limit when x tends to minus infinity of this function. Let's go to do the limit when x tends to infinity. When x tends to infinity of this function, 3x minus 2 divided by square root of 2x squared plus 1, if x tends to infinity, 3x minus 2 is the same thing that 3x. And 2x squared plus 1 is the same thing that 2x squared. So square root of 3x divided by square root of 2x squared is the same thing. Now, if I divide by x in the numerator and by x in the denominator, I have not altered the fractions. So x divided by x will be 1, and 2x squared divided by x, if I put it here inside the radical, inside the square root, I have to put it like x squared, so it will be 1. So it will be 3 divided by square root of 2. So the answer is that when x goes to infinity, the limit will approach the number 3 divided by square root of 2. 3 divided by square root of 2 is more or less 3 divided by 1.4. It is more or less, should be 1.9, something like this, 1.8, whatever, what is the function. Now, if x approach to minus infinity, the function, when x approach to minus infinity very far to the left, the function approach of minus 3 divided by square root of 2. So there are two horizontal asymptotes in this problem. Let's go to the next one. No, there is no next one. So we have finished lesson 6.